Hi, everybody. This is Talking Digital Industries, the podcast for technologies and trends that drive industrial enterprises. And me, I'm your host, Chris Brown. In our episode today, we discuss one of the, or maybe even the most important technology of the 21st century. I'm talking about artificial intelligence. Now, every day we get in touch with this technology. It's changing our lives. We might not even notice necessarily. I'm talking about, Google search queries, for example, digital assistants with voice recognition like Siri and Alexa, self-parking vehicles. And also in industrial production, AI is increasingly enhancing the capabilities of machines and humans. The use of AI opens up completely new opportunities in estimations of market demands, product design, production floor, and to the supply chain. So what will the future look like with more intelligence in production processes? I'm looking forward to an exciting discussion with an amazing and also pretty big round of guests here. I'm going to start it off with Ewa Duerr. Once a professional violinist, she is now the head of product strategy and operations and cloud artificial intelligence at Google. Welcome, Ewa. Great that you could dial in from California. Just say hello to our audience out there.
Great to be here.
All right. Also joining us here today is Dr. Matthias Loskyll. He is the Director, Advanced Artificial Intelligence at Siemens Digital Industries, where he is responsible for the development of AI-based innovations for industrial applications with his team. Happy to have you here also. Matthias, how are you doing today?
I'm good. Thanks, Chris. Happy to be here as well.
All right. And to complete our round, I'd like to welcome Dr. Ulli Waltinger. He is the head of the Machine Intelligence Research Group and the technology head of the Siemens AI Lab at Siemens Global Research Organization Corporate Technology. He says about himself, I am interested in combining human intelligence with artificial intelligence methodologies. Great that you're joining us also. Ulli, how are you doing today?
Chris, thanks very much. Honored being able to join this awesome round.
All right. Now, before we start, a quick note. We are recording remotely, just so our listeners know. Everyone is somewhere else. We're basically scattered across the world right now, from Germany all the way to California. So if the sound quality isn't 100%, don't worry. Our guests are 100% on point. But now let's begin. And my first question goes to Ewa. Now, Ewa, I guess you could call this a career change to the extreme. You were an orchestra violinist. Now you're driving Google's cloud AI product strategy. How did that happen?
Well, there is definitely a link between music and artificial intelligence. My background in music definitely nurtured my right brain capabilities, fostering creativity, but still today helps me to think out of the box. And exactly that, the combination of art and science, right and left brain capabilities is crucial in today's business world, particularly in artificial intelligence.
I fully agree. I totally get it. I'm a musician myself, actually, in my second life, you could say. A bit of a different music style, but maybe we can, team up one day. You play the violin, I put a rap on it. We'll see about that. But what about Ulli and Matthias? Any talents, music talents, maybe?
Yeah, maybe funk and punk would summarize, I guess, my passion for offbeats, right? Being a drummer many moons ago.
Nice.
And driving nowadays a bit of jazzy tunes.
Cool.
Playing in a band is also a great way to, learn about, I guess, team dynamics, egos, right? Who loves the drummer, who likes the bassist, but also about performance in teams.
Nice. And you, Matthias?
I started my career as a piano player when I was 5 years old, but actually was only able to play Beatles song yesterday, so I finished my career again a few months later. So sorry, I'm absolutely not musical. I think I'm the only one in this one.
But you know what? I think it'd be enough to start a virtual concert or something. The next time we get together, we should bring our instruments along, and I'll bring some raps along. But before we go deeper into our topic of AI in the industry, let's briefly summarize where we generally stand. Now, AI is certainly one of the most important current buzzwords. It's finding its way into more and more areas of life. And sometimes, we don't even notice that. Ewa, what are your favorite examples of this invisible daily AI, you could say?
Where there are multiples, but what is interesting is to recognize first that AI has transitioned from being a research topic to a technology that is already today affecting billions of people.
Mm-hmm.
And coming back to the invisible AI, one of my best examples is coming back to the music topic. ML can be used to foster creativity via style transfer learning to compose new pieces of music or design art. I sometimes do it as my hobby whenever I find free time and experiment with that. Encourage others to do that as well. But coming to a more B2B space where people don't notice that AI is being used, it fosters customer experience and drive efficiencies. For example, in a call center, in the past, what businesses had to make is a trade-off between great customer support and operational efficiencies. This doesn't have to happen any longer. Today, conversational AI technology provides a consistent, high quality customer experience across all channels. It's merging human service and virtual experience. It centralizes the ability to talk, understand, and interact. So these are the areas that already make an impact. Another example that drives huge efficiencies is document processing. Image recognition technology allows to extract relevant information. Natural language processing technology allows to classify the content. Sentiment analysis allows to contextualize it, assessing prevailing opinions, feelings, sentiments, etc. So these are the areas that drive tremendous time and effort efficiencies in the corporate world.
Obviously, there are many areas where we don't even notice, obviously, that AI is already a main part, a main element of the technology. One thing that really stuck in my head now, what you said, is that it offers service and efficiency, which I've experienced on my own also when I call a company. Another thing is, voice and image recognition have evolved significantly, but still often don't work properly, not 100%. What is still lacking to make it perfect?
It is a fragile beauty, I guess, right? Isn't it? So even though if you look on the image classification, right, the last 5 years, we improved from, 75 to, I don't know what, 88% accuracy and, top accuracy almost 89. Though it's on scientific benchmarks, right? Speech recognition, the same, right? Shout out to our lovely Sepp Hochreiter and Schmidhuber, right? For LSTMs, the one of the deep learning modules and models around it, right? Improving the last years, the error rate, from 15 down to 5%. So there are tremendous achievement improvements in what I call the deep learning revolution. In terms of corporate research as well, right? Mostly of these benchmarks are led by corporate research, but also on scientific benchmarks. And I guess that the problem is our flawed belief that if we have enough fuel these algorithms with enough data, that our algorithms somehow substitute our human problem solving. Though if we look in our real world, this real world is not as clean as a scientific benchmark, right? It's much more dirty and much more unknowns, right? And therefore, these appearance shortcomings that these algorithms still have, right, reflect somehow how its robustness, but also the adaptability, and these remain challenging. Well, that means obviously, AI has its limits, but its commercial impact has just begun, I'm sure.
Okay. Eva, anything you'd like to add?
I can only echo what Ulli has said, and I believe this can be vaguely compared to humans. The more you do something, the better you learn it, right? And the scientists have demonstrated already a long time ago that as you practice something, your memories pass from short-term memory to long-term memory, sometimes even to unconscious levels of the brain. And there are multiple aspects that contribute to that learning, being a diet, sleep, stress control, and so on and so forth. Similarly, as with the human, in machine learning and in artificial intelligence, you can nurture that training. And Ulli mentioned already data being one of those aspects that play a critical role, but not only. It's a variety of machine learning techniques and algorithms that provide an even better experience and final outcome. That's the combination of supervised and unsupervised learning techniques, numerous algorithms, LSTMs, CNNs, RNNs, federated learning as one of the latest ones that we have been experimenting with. And combination of those can drive an even better outcome. And if you think about it, this is an optimization algorithm in itself. Which ones do you choose? How many layers, how many nodes do you pick up? This is an optimization effort that requires some learning in itself to achieve better outcome for a particular use case.
Basically, you could say the only thing lacking is time.
I think we are getting there.
So to give everyone a better understanding of this technology, let's provide our listeners a short history of modern AI. And if you think about how it evolved in the past years, how it evolved from the first AI programs, so to say, which were able to, I don't know, master a game at checkers maybe. What form of AI exists today, and what can we do with it today, and what not? Now, Ulli, you already mentioned, like, there are limits, of course. So what can we do today, what not?
AI, I guess, is a young discipline, right? What is that? 60, 65, 70 years? And it is
I
actually,
guess in the 50s, 60s.
Yeah, something like that, right? So it's a set of science and theories and techniques. It's targets towards, we want to imitate the cognitive abilities of human, right? That means we have these disciplines. How do we perceive, like image, voice recognition? How do we learn from data? Currently very hyped. How do we reason about doing logic? Uprising hype, or how do we interact with natural language processing, right? In a natural language assistant way. AI has in the last 10 years, let's say, significant made progress in the application. And the decisive factors were the quantity of data that is now available, the increase in the computation power, obviously, right? As GPUs, TPUs that we have and can now scale out in cloud and edge environments, the ability of free software development kits, really important. I call that actually the revolution of a young next generation in AI, which triggered the hype also in AI. And obviously further development in the architectures of machine learning, especially, right? And therefore, the outstanding successes that we experienced over the last, let's say, 5 to 7 years, we can, relate to a discipline which you may want to feel called narrow AI or weak AI. So let's say supervised machine learning algorithms, here especially, deep learning nets. We've already heard from Ewa a bit about, a number of layers, number of neurons and stuff like that, right? These have quite an impact. And the difference is these have quite an impact not only in the academia world, game of Go, right? AlphaZero, tremendous, but also in the corporate world. And these narrow AI systems are fueled by input data, let's say a fuse of images or fuse of ads, are optimized themselves towards a single target variable. That's why we call it narrow. Let's say, you will click on an ad or not. And we can train these systems very effectively on these narrow tasks. And these AI systems and these algorithmic decisions, basically, right, influence more and more current elements of everyday life.
Right.
It's the interaction in the household. You say that already, right? Home assistants, Alexa, Siri. You have, search and advertising offerings. It estimates maybe who you date, right, or what you like, or what you're interested in,
right.
what direction you go. The diagnosis of medicine, the definition of personal credit lines. These single tasks are quite appealing, quite effective, and can be trained very effectively. On the other side, we still have this capability of fragility, robustness. How do we manipulate even these kinds of systems? These are still a lot of questions and research questions to be answered and tackled, isn't it?
So I guess we could say it touches every aspect of our everyday life. And the next question go to Matthias, because I want to focus a bit on the industrial applications. Where do we find AI in industrial applications mainly?
Chris, in the meantime, these forms of narrow AI, as Ulli just explained, they also arrived in industrial applications, actually. So in terms of applications, you can see topics like data-driven systems that enhance machines with certain capabilities like perception, for example.
Mm-hmm.
You can see intelligent algorithms that allow logical reasoning, as Ulli mentioned, but also more and more there are even more advanced skills that go in the direction of autonomous systems, for example. And in terms of technologies, you see everything from the AI toolbox, so to say, from classical machine learning to the most modern neural networks up to reinforcement learning. And all of this is coming actually to industrial applications. So most certainly, the most applications can still be found in analysis of big amounts of complex data. That's clear. That's the first step. And this doesn't have to be always shop floor data or factory data only, but we see that it's coming up to the whole life cycle of products, like also data coming from design and engineering and simulation. And all of this combined can really create powerful applications in our industrial world.
Why don't we have a look at some concrete use cases of artificial intelligence for manufacturers? What can AI do on the factory floor and even beyond?
So let me start with some very typical use cases that you see all around the world, and then let's have a look at a few more fancy ones, let's say. So what almost every producer today is working on is something like anomaly detection or predictive maintenance systems to reduce plant downtimes, for example. You can imagine it like an early warning system that helps you to better schedule your maintenance of machines and components rather than reacting when the failure happened already. Right? So this is a very typical one. It's a bit like a low-hanging fruit, but still complex enough to implement. And another typical example that we see all the time is using AI for quality assurance or even inline quality prediction, how we call it, of your products that are manufactured. So this means that a manufacturer is enabled to predict whether the product that is currently in production will be a good piece or scrap. And this is based on process parameters, for example. I think Rainer Brehm actually talked about one of our examples from the Siemens factory in Hamburg in the first episode of this podcast. This is exactly what I'm talking about.
Yeah, that's right.
And the more fancy stuff actually happens in the area of autonomous systems. So, for example, handling systems or robots that become much more flexible and much more intelligent. They can even grasp unseen objects in the meantime, rather than being programmed for doing the same task all day long. So in general, I believe AI will convert our machines and factories into kind of self-learning objects that continuously improve themselves and optimize the process.
Wow. Now, many tasks, obviously, I haven't thought about before, but if you needed to sum it up in one sentence, what would the main benefit be for a producer to integrate AI into their processes?
So I'd say it's the optimization of the processes across the whole life cycle of the product. So starting from design over the manufacturing itself up to the supply chain or the delivery in the end.
That was one sentence, Matthias. Nice. How about you, Ulli?
I guess I go for speed, scale, efficiency, right? Meaning improve the customer experience, support employee performance, and increase productivity through smart automation and AI-driven augmentation. Is that a sentence? I'm not sure. Or paragraph.
You guys are good. Okay. Maybe you could tell us what industries might be like pace setters in the use of AI. You know, what industries will lead the way and why?
I wouldn't say it's just one specific industry. We see actually many examples in automotive, of course. The big players invest quite heavily here, but also in electronics or food and beverage or other industries, AI is applied in a broader sense now. In the end, every producer that has to reduce plant downtimes, for example, or has to optimize production processes, has to increase throughput, for example, they could use AI for this optimization purpose. We'll find this way from mass production that we see a lot today to more customized production. And for this, you need to produce in a more automated manner and to make it profitable in high-wage countries in the end.
So what would you think when you think about the factory of the future, right? For this, we still have to use our imagination. AI hasn't gotten that far yet to be able to actually have us look into the future. But just imagine, what would the factory of the future look like? What will AI in it achieve and change? Ulli, maybe you start this time.
Let me quote a favorite Twitter meme here. It says like IoT, right? IoT is when your toaster mines bitcoins to pay off its gambling debts to the fridge. Do you know that? So I found that hilarious, but it also shows, right, that we have still a bit of a road ahead. But once we are this road ahead, right, meaning smart machines are connected, communicating with each other and improve on certain tasks, right? That means it will be pretty interesting, pretty awesome, and it changes the perspective on industrial AI, and it changes also how do we interact with smart machines. If we look at currently, right, most of our data is not labeled. There's no approaches how to deal with these massive amounts of unlabeled data, and therefore I'm really puzzled and but also excited about new approaches towards unsupervised learning, self-supervision. How do we encode, domain know-how, symbolic learning, what we call it? How do we make sure that simulation matches the power to AI? It's super interesting, right? And on the other side is the robotic side, obviously, right? What if machines define and shape the data so they have their actions, right? What about watch and learn? It wouldn't be great to have machines really can mimic us and watch certain tasks. So complex robots compile and do complex tasks, assembling products only by watch and learn and visual demonstration, without any talking, maybe, or with talking to humans. Say like, oh, can you give me that, right? Similar as the job would do. I'm really stoked about the next wave of AI towards industrial productizations. And that means for us, I guess, right, statistics on steroids, let's say machine learning, meets automation on steroids, means robotic system on the factory floor. Awesome.
Just from the tone of your voice, Ulli, you can hear how excited you are just thinking about this topic.
I do.
Matthias, how about you?
Yeah, actually, I see some of these trends coming as well, as Ulli just mentioned. And it's not so much science fiction anymore. We actually see in some top research institutes these kind of imitation learning where a robot learns from the human, just like watching a video of a human. And I think this is really fancy stuff. It still has to prove its value, obviously, in industry. This is the future. And we see that we need to adapt these technologies because, as I said, this trend of customization and more flexible production, having production islands that are combined by intelligent mobile robots moving around in the factory, this is really a clear trend that we see coming in the next years already.
So let's be excited about that. And as we do embark on the next wave of the Industrial Revolution, shouldn't we somehow define how we want to work together with machines when decisions are made based on AI and not on humans? I mean, isn't that an issue? Eva, how about you? What do you say about that?
I think a couple of things have been already mentioned, and Ulli said human oversight is one of the key areas. As we recognize that AI, such a powerful technology, raises equally powerful ethical questions about its use. And we, as corporations that drive this market and will shape that market in upcoming years, we have that responsibility to get it right. And most importantly, we need to work as a community. And I think that's what Ulli mentioned already before, with the government's educational institutions, and promote ethical and responsible use of AI.
True.
Right. Talk about an ongoing process. Matthias, what's your opinion?
Yeah, I totally agree. So explainable AI is really crucial, in particular also in industrial applications. I mean, engineers typically want to understand why a system behaves like it behaves. So they really want to understand the inner working. And if we think about human operators in the factory interacting with AI models, then it's really crucial to have this kind of explainability in the end.
Ulli, would you like to add anything to that? I mean, what do we have to work on to work together with machines?
I think Eva and Matthias nailed it. The main idea in AI is, IT meets OT in the industrial AI. That means like we transform a given data into actions in the real world, right? And these actions, these have costs and benefits. And these actions are currently also predicted under uncertainty. We know it's not 100% sure, right? So we need to balance this uncertainty with regard to the consequences. And as most of systems have failure modes, we can measure them: accuracy, false positive rate, false negative rate, you name it. So how do we make sure that when we maneuver data into real world action, that these reflects the decision making of people and the customers and the partners as they want to have it? Especially in industrial AI, if you shut down a certain line, a product, a compressor, this costs high margin. And people, domain know-how and experts and partners want to know why. And that's why it is of vital importance to take over and also to emphasize the aspects why a certain decision is being made.
Right.
And this why needs to be inclusive to the actual operator, to the actual business partner who is, interacting with with these technologies.
It's often said that AI will at some point make decisions that are too complex for humans to trace. And I think Matthias said before, engineers want to understand more, but how can we also achieve a better understanding, like even I, of the machine mind that might be essential for making trustworthy AI? Like you all know R2D2 or C3PO in the famous Star Wars movies, right? Like for me, those are trustworthy figures, AI figures somehow. How can we make AI more trustworthy in general? Ulli?
When IT meets OT, we need to include the human directly. Yeah. And that means not only in terms of building different perspectives in terms of the data we use, but it should be holistic. We must value, in that case, diversity in all its dimension, not only in terms of the data, not only in terms of that it's an outstanding innovation performance, but also as it is elementary to reduce bias and gain trust in AI. Because it's about deployment, it's about how we update, it's about how we interact with that. And I think this comes along with jointly together developing solution, what we call co-creation, but also about learning how capabilities and risks and failure modes can be detected.
But it's probably also about responsibility. Now, who is responsible for the resulting actions of artificial intelligence as it grows and grows? I think this will be a question that will pop up more and more. Ewa, would you like to answer that?
We definitely need to work as a community and an ecosystem of corporations, governments, regulatory, educational institutions, as was mentioned before by Ulli and Matthias. And I think we have already been taking steps in the right direction. Things like GDPR or regulations for medical devices like AI-assisted heart monitors already serve as a strong foundation for governing AI in some areas. And those new rules could require companies to be transparent about how they build their systems. But this regulation needs to be proportionate, balancing potential harms and social opportunities. And this could be tailored to different industries differently. Like medical applications and self-driving cars might require different rules. And I think governments should align their rules and agree on their core values.
Thank you, first of all, for that answer, Ewa. If we look at the industry more specifically again, and also referring to our podcast title today, is this all more a risk or is it a chance? Matthias, what would you say?
So for me, AI is clearly a huge chance for industry. So certainly we have to be careful, and we talked about risks and needed regulations, sure. I want to bring another point, actually, that's in particular important for industrial applications of AI. So what we see a lot is that many AI projects do not make the step from what we call proof of concept to really roll out and productive use in the factories. And the major reason is that we do not think so much about operations of AI. So always the model is developed and then it is deployed, and without taking care of like more professional testing and validation, and how does the AI really behave in unseen situations, and how can we make sure that we kind of monitor the AI models that have been deployed in production facilities to detect some drifts of the model and to see and react if something goes wrong. And this is crucial in industry because we are talking about very expensive hardware setups. We are talking about applications, robots that are moving around.
Thank you very much, Matthias. Let me ask one big question at the end of our discussion here. in the long term, when will machines basically surpass human cognitive abilities? When will AI be smarter than man?
We have to recognize that partial intelligence, narrow intelligence, has already surpassed human capabilities in selected areas, and we have to live with that.
Mm-hmm.
As similarly selected animals, if you pick, let's say, bats that can hear ultrasonic sounds, or eagles that can see at a meter their prey 20 times better than humans, still we have been living with those animals for ages,
Mm-hmm.
and in a peaceful manner. So the more important and overarching principle here is we need to ensure the human oversight over those AI systems. We need to work as a community and, for example, be practical. How do we design UIs so that it doesn't result in confirmation bias? Community have already shown that we can deal with those challenges that lay ahead of us.
Mm-hmm.
Like, for example, how we dealt with cloning, stem cells, or current discussion on CRISPs in genetics. These are the areas that we have shown that we can deal with in a reasonable manner. So I'm cautiously optimistic that we can handle that here as well.
Cool. How about Matthias?
Yeah, to be honest, this all super AI discussion still sounds a bit like science fiction to me, even though I'm an AI expert. So I believe that we will see many breakthroughs, certainly in the next decades. It's pretty clear. And there are some really outstanding technologies coming up already, like spiking neural networks, or reinforcement learning is getting more and more applied in a broader manner. However, don't think that we will ever experience, or at least not anytime soon, this kind of super AI in the sense that it's able to outperform human strategic and creative thinking.
Mm-hmm. Ulli, would you agree, or what do you say?
Yeah, somehow I agree, right? I would also leave the super AI discussion to, crazy and inspiring TED Talks, right? And we would rather say, let's shape a future orientated, sustainable society with a responsible use of narrow AI together right now.
Thank you very much. I see time has already run out again, unfortunately. I'd like to thank you all for these really interesting and really intelligent answers on the topic of artificial intelligence here today. So from my side, a big round of applause to the three of you, Eva, Matthias, Ulli. Thank you very much. Did you guys enjoy it?
Absolutely. Thanks a lot.
Awesome. Thanks very much.
And also a big thank you to our listeners out there. As usual, at this point, just a few hints for further information. Just go to www.siemens.com/stories/AI. And also stay tuned for the next episode. This is Talking Digital Industries, and I can't wait to hear you again. Bye-bye, and take care.